Hello everyone, welcome to Geeks for Geeks. So let's talk about today's problem. Our problem name is burn tree. So let's read the question first. Our question is given a binary tree and a node data and target. Find the minimum time required to burn the complete binary tree if the tree is set on fire, right? So it is known that key in 1 second all the nodes which is connected to that particular node will get burned, right? So that is its left child or right child or its parent, right? So that's the question, right? So let's understand this particular question better. So here we have three things. So let me first copy this. Okay, so see here. So this is my tree, right? Where the question simply give me the root of it, right? That's the root of it, right? So we just have to give the target node. Target node is 10, right? So question said that particular node is start to burn, right? So that particular node is start to burn, right? So what we have to do is, if that particular node is start to burn, the node which is connected to that particular target node, either it's parent of it, either it's left of it, either it's right of it, that will also burn. That particular three nodes will burn in 1 second, right? We just have to calculate to burn all the tree. We just have to calculate how much minimum time required, right? Okay, now see, this is my target node, right? Just focus here. This is my target node, and with this now only this particular node will be burned, right? Because its left is not there, its right is not there, only the parent is there, right? So that particular take first second, right? That's why I just write first here right now. Okay, now if 5 is also burned, right? So you just have to burn its left, right? So left is already burned, right? Right is nothing is there in the right, so parent will be burned, right? So that means that is also burned. How much time take? 2 seconds, right? Till now we just take 2 seconds. Okay, now when we are at 2, right? So we just burn which is connected to 2, that is your this node and this node, right? Okay, because 2 ka parent is 1 and 2 ka left is 4 and 2 ka right is 5, which is already burned, right? Okay, so that particular time take 3. Let's write here time 3, right? So 3 seconds. Okay, so let me write here 3 seconds as well. Okay, now see, now we have 8, right? We have 8 that will be burned, right? Okay, because 4 ka parent will already burned, right? And right now we are at here, and with the same second, which is 4th second, we burn the 8, we burn the 3 node, right? Okay, because 1 is also at 3 second and 4 is also at 3 second. With 1 second, whatever the node which is connected to 4, it's burned, right? And whatever the nodes connected with 1, it's burned. So we have 3 and we have 8. So this is at 4th second and this is also at 4th second, right? Now if you see, all are burned, right? All are burned, only 7 is left. Now 8 ka left is not there, 8 ka right is not there, 8 ka parent is already burned, right? Okay, so 8 is finished, right? Now we are left with 3 ka left is not there, 3 ka parent is already burned. Okay, 3 ka right is there, so that particular node burn at 5th second, right? That's why our output in this case is 5, right? The minimum time we have to take to burn all the tree is 5 seconds, right? Like this we have to solve it, right? Simply you just have to focus here, left, right, and parent of it, right? Okay, so that's the pretty much clear for the how we think about it, how we solve that particular problem. Okay, now let's see how we can make the code of it, right? Now if you see here, every node, for example 1 is there, what we have to check, it's left we can access, right we can access, right? In the tree we can access its left and right, but how we can access the its parent of it, right? So that's the pretty straightforward, right? We just have to solve that particular problem, how we can access 1 ka parent, right? For example 1 ka parent is nothing here, so for example 2, so 2 ka left is 4, okay, 2 ka right is 5, okay, so 2 ka parent will be 1, but how we can access that? We can access that, right? What we have to do is, that's the step 1 to solve that particular problem. What I am doing is, I simply make a child parent map, right? In that particular map I simply write, okay, that particular car child or that particular car parent, what is that parent, right? So what I'm doing is, in step 1 we make a map, right? That particular map contain key value pair, as I know, so the key will be child and the parent will be your value, right? we just have to make like that. Okay, so let's do the dry run step by step so that you can understand it, right? Okay, now if you see here, what I'm doing is I simply make a map, right, which is on a node and make the m, right? So we go to the helper function. In the particular helper function, so let's copy paste this helper function and try to did that part. Okay, now in that particular case, what we have to do is we simply make a map, right? And see here, this is my map. Okay, so in that particular case, what I'm doing is I simply make a queue, right? Using queue, we can easily traverse all my map, right? Using the BFS part. So what I'm doing is I make a queue here. So let's make a queue as well here. Okay, so in that particular queue, what I'm doing is I simply push the root itself. So what is root? 1, right? And I know that that particular 1 ka parent will be null, right? So what we have to ask here, it's null. 1 is your current, right? That is your child 1 ka parent will be null, right? That's why we just do that steps, right? After that, we know that key 1 is there, right? 1 is there. So what we have to do is we just have to check. Okay, so what is the current value? Is 1. Let's pop this here. I just write the current value will be your 1, right? And after that, I just ask, its left is there? They said yes. If left is there, it means whatever your current ka left, that is child, and what is the parent of that particular child? It's current, right? Okay, so what we have to do is this there? They said yes. 1 ka left is there. So what I can say that is your current, right? That is your child, and this is your parent, right? So what I'm doing is I simply go to the map, right? And what I'm asking, okay, map of current ka left, which is 2. Its parent will be 1, right? Simple. Current ka left is your child, right? And whatever you are at point, which is current, that is your parent, right? Like this. And at each step, we just have to add that particular parent, current ka left as well, which is 2, right? Like this. Again, we check what if 1 ka right is there. They said yes, we have. So what I'm doing is I simply add 3 here, and that particular is your child, and what's the parent? Current is the parent. Let's add it, right? Like this, we can easily complete my parent child relationship, right? So this is called as child and this is called as parent, right? Okay, now after that, what we have to do, go to the while loop, and that is 2, right? Now we are at 2. Okay, so let me cross this, and this is your current right now. Okay, this is your current right now, and I'm asking its left is there? They said yes. So what I have to do is 4 is your child and 2 is your parent, right? Like this, we just have to do that. Okay, and after that, its right is there? They said yes. So 5 ka parent will be 2. Like this, we just have to do. Okay, after that, we just have go to the 3, right? We are at 3. This is my current right now, right? And I'm asking left is there? Says that they said no, it's not. What we have to do, we simply ignore that part, right? And go to the right of it, and we have something in the right part. 7 ka child will be 3, right? And here we just have to push 7 here, right? Like this. Okay, after that, we just go for 4, right? Now we are at this pointing. Its left is there? They said yes. So what we have to do is 4, 8 ka parent will be 4, like this, and add here 8. Okay, like this we can able to solve this. After that, we are at 5. Okay, its left is there? Yes. What I have to do is 10 is your parent, and whatever the 10 is a child, and what's the parent of 10? That is 5, like this. Okay, after that, we just have to add here 10 as well. Okay, after that, we are reached to 7, right? We are here, nothing is in the left and right? So simply ignore that part and go to the next, which is 8. And here also nothing is there in the left and right, ignore that part. After that, we are at 10, ignore that part, right? So how many nodes you have? 1, 2, 3, 4, 5, 6, 7, 8. Like this, you can calculate every child parent will be there or not. 1, 2, 3, 4, 5, 6, 7, 8. Yes, it's correct. Now that particular map will store your child parent relationship, right? Because in the question itself said you can check in the left, you can check in the right, and you can check that particular node ka parent, right? So here what we have to do is we simply do the first step and make that particular child parent relationship so that we can also access that as well, right? Okay, so that's the thing which you have to keep in mind. Okay, so I hope you understand the first step, right? And let's make that particular map here so that it's helped me to dry run that part, right? Okay, so that's a simple intuition, that's a simple steps with where helper function help us to make the child parent relationship in my map, right? Okay, now at the second step, what we have to do is, okay, let me, okay, in the second step, what we have to do is, let's make that particular map again. Okay, sorry, tree again, because we have to make again. So let me write here 1, and we have 2, 3. After that we have 4, 5, 7. After that we have 8 and 10. Okay, so these are the things. Okay, in that particular case we already got that particular as your target node, right? And I just want to make that particular pointer here, right? So what I'm doing is, in the second step we just have to ask, right, can you please give me that particular node which we have to, where, from where we have to start, right? So what I'm doing is, in the second step we just do the find function. Find function, with the help of find function I just make a new node, right? For example, the node itself will be given to it, right? And using the find function I just want to make that particular pointer here, right? Okay, okay, you understood, right? Let's first do the dry run so that you can understood. In the find function, okay, let me copy paste this. Okay, now see, in this case what we have to do is, okay, now see, in that particular find function what I'm doing is, we have node, right, root, which is the starting pointer, which is this, right? So in that particular case target node is this. Now my node I just passed, right? So that my main function will know that that particular is your node, that is your target node, right? So what I'm doing is, I simply make that particular find function and see how it's work. Now my root will be 1, right, and the target will be 10. Okay, and the node will be right now, let's see, in the helper function, what in the main function we have node right now, it's null, right? So here it is null right now. Okay, so I'm searching that particular 10, right? What we have to do is, go to the that's your base case, right? Go to the left of it and go to the right of it. That's your two options, right? And what is your base case? Base case is simple. When it's null we just have to stop here, and when we reach to the target, what we have to do, we simply make that particular, where we make the node, that node is pointing to this node, right? And return back, right? Now my node, a variable, is pointing to that particular target node. That's my target to that part, right? For example, I just want to reach to that particular node. Because why we reach to that particular node? Because if you see in the question now, target is your integer part, it's not your address part, it's not the pointer part, right? It's the integer part. That's why we just have to do that particular second step, so that I just want to make that particular pointer, right? Because at the end we just have to point to the next left, right, and root its parent itself, right? But we have the target as a value, right, as a data, as an integer, but I want the pointer. That's why what we are doing here. So let's see the target. What we have to do, go to the left part, this is 2, right? That is 10, and what is my root node right now? Null, right? Again we go to the left, we have 4 and 10 and null, right? Again we go to the left, we have 8, right, and 10 and null. In that particular case, go to the next, it is null, right? What we have to do, we go to the base case and return back. Again we go to the right of it, go back, right? Nothing is there. In that particular case, what we have to do, 4 ka right is, which is null, go to the back, right? In that manner we reach to the 2, and in that particular case what we are doing, we go to the right of it, right? And in the right part we have 5 and 10 and null, right? Again we are not able to reach that particular, if root data equal to target, what we have to do, go to the right of left of it, that is 10 and 10, right? Here if you see, that particular if condition satisfied, right? And root ka data equal to target, they said yes. Now your node will be that particular root, right? So right now my, let me make different color, no node will be this, right? Now my node is pointing to this, and at the same time I just return back, return back, return back, because my work is complete, my task is complete. In the second step we just have to point to that particular target node, right? We successfully do that. Okay, now if you see, our task is completed, right? So that's my target. Okay, I hope you understand the two steps, right? Now we are at the last step, that is the most important step. Okay, now let's do the try run for this case. Let's rub this part. Now let me copy paste this and ignore this part. Okay, Now we have the target, right? The node is pointing to that, and we have the child parent relationship, right? Okay, now what we have to do is we simply do the third step. Using third step, what we have to do is we are at the node pointer, right? We start from this node and we go to the left of it, we go to the right of it, we go to the parent of it. If anything is not visited, that particular thing will be count plus plus, right? For example, what we have to do is, right now we are pointing to here. What I'm doing is I simply make a visited array, or you can say that map, where we can tell that particular node is already burned or not, right? Okay, so we just have to do that part, right? That particular node is burned or not, because when we reach to this case, we go from 10, go to the 5, go to the 2, but at 2, see here, at 2 we go to the left of it, we go to the right of it, but right of it is already visited. We came from 5 to 2, right? Why you are visiting that particular 5 again, right? That's the thing which you have to do in that case, right? We just have to make the visited array so that I can mark that particular node is already visited or not. In the previous case it's not visited, so we just have to mark that particular node as false, right? It's not visited right now. Okay, so that's the thing. Okay, so let me show you the code. The first step is completed, right? Parent array we just have to make. The second, we just have to point the node into that particular target node. Okay, after that what I'm doing is I simply make a queue, because we just have to do the BFS of it, right? Okay, that's why we just make a queue of node, and in order to map, what we have to do is we just make a visited array and mark all as unvisited right now. That's why we just make false right now. Okay, so your key will be the node, right? That particular node is visited or not, and you just have to store bool value, true or false, visited or not visited, right? Like that. Now in that case, let's copy paste this as well. Okay, so let me tell you a bit of it, like what we have to do. Okay, see here. So here we just make a queue as well. After that we'll read the your code part as well. Okay, now in that case what we have to do is we just have to, the time will be 0 right now, right? The time will be 0, and we just have to push that particular starting node, which is 10. So let's push that particular into it and mark that particular 10 as true, right? It's visited, right? Now what we have to do is we simply check, okay, what's the size of that particular queue right now? They said 1, because you have only one node in your queue. That particular is only burning right now, okay, at first second, at 0th second, right? Okay, now see, the size will be 1. We just have to traverse my loop, whatever the size you have, right? Okay, so in that case, if you see, your size will calculate, and flag will be false. Later on you'll understand like why we are using the flag right now will be false, right? Okay, now that particular node will be pointing, and just pop that part. Okay, now the first step, we have three things now. Go to the parent, go to the left, and go to the right. If you see in the code part, what we are doing is, right now current will be my 10, right? Okay, we just pop it, and we just have to check, okay, what's my parent? So parent here is, if you see here, what I am doing in the parent part. Okay, what is parent? Here simply I write, okay, your current will be 10, your current will be 10, and what is the parent? Parent simply m of 10, right? Whatever we stored, m of 10, which is 5, right? So parent will be 5. Like this we can access that, right? Okay, now what we have to do is we just have to ask, is parent null? Because one ka parent will be null, right? No, it's not null, right? Okay, can you please tell me that 5 is visited or not? They said, okay, 5 is not visited, right? 5 is false right now, because anything which is not present right now, just assume that it's false, right? 5 is not there. So what we have to do is we just have to make 5 as true and put that particular into queue, right? Okay, now as that particular is, what I'm doing is flag will be true, right? It means that at that particular case you burn some node, right? That's why we just make that particular flag initially is false. It means right now you are not burning any node, but when flag equal to true now, it means either you burn the current ka parent, either you burn current ka right, either you burn current ka left. That's why we just make the flag part, right? We just have to do that. Now my flag will be true, right? Okay, now the first part is you go to the parent, the second part is go to the left of it. Okay, left ka null, left current car left is null. They said yes, it's null. So I'm not able to access that part, right? Current car right will be null. Yes, it is. Yes, it's null. So see here, when we go into this case, we just have to ask parent car null. It's null. They said no. We just have to do that part, right? After that, go to the left of it, and I'm asking current car left null hai. So they said yes, it's null. So I am not able to access that part. Similarly, we are not able to go to the right part, right? After your for loop will be finished, it means in the first second you have only one node, right? That's why here I'm checking if flag equal to true. They said yes. If it's flag equal to true, it means at that particular case, at that particular second, you burn some node, right? That's why which thing will be one, this thing will be one, right? That's why let's write one first second here, right? At the end I am asking flag true. They said yes. Please increment my time because at that particular time will be 0. Right now it's 1, right? Okay. Now after that, what we have to do, again go to the while loop and check what is q is pointing to the 5, right? Okay, right now you are pointing to here. So let me write here, this is your current node, right? So let me write with this color. So this is your current. Okay, okay, now I just pop that part and I'm asking its parent is, so let me write here, current will be 5, and what's the parent of it? Parent is 2, right? You can check like here, what is the m of 5, which is 2, right? That's it. Now I'm asking, is this null? They said no. Is this wasted? They said no. Let's add here and let's add into it, which is 2, right? And let's make your flag true. Initially it's false, every time it's false, after that it's true, right? Okay, now I'm going into the left of it. They said okay, it's 10. Is this null? They said no, it's not null. Okay, now see here, I'm asking current ka left null. They said no. Okay, and that particular is visited false or not? That is not false. That's true, right? Because 10 is already true here. Do not go into that because it's already burned, right? Okay, after I go to the right of it, it's null, so do not go into that. Now what is your flag? Flag is true, right? Because in that particular case, in the parent part, we burn that part, right? We burn that part. So this is a second, right? Okay, so at that time my current will be 2. Okay, now in that case, let's refresh this part. Now your flag again falls because you start from the fresh state, right? And in that particular case, what is your current? Current will be 2, right? Okay, after that, go to the parent of 2, which is 1, right? Parent will be 1, right? I'm asking your parent is null. They said no, it's not null, it's 1, right? Okay, so after that we have to ask, okay, your parent is visited. They said no, so let's make mark as visited and add here, right? And mark that particular flag equal to true because you burn that part, right? Okay, after that what we have to do, go to the left of it, it's null. They said no, it's not null. Okay, that particular is burned or not? They said no, it's not burned. So what we have to do is we simply mark that particular as true because it's visited and mark here, right? Flag equal to 2 because it's true, just overwrite that part again, right? Again it's true. Okay, after that, this is already burned, right? Okay, after that, where you have to go to the, okay, 2 ka right is there, which is 5, that is already burned, right? So in that case, is your flag true? They said yes. Please increment that part, right? Like this. Okay, after that we reach to the, what is the size of it? 2, right? In that particular case, we again mark that 2, right? Right now it's already covered, right? Now you are at here, what's the size of it? 2. Q ka size will be 2. It means your for loop will run 2 times. Okay, because this is finished at third second and this is also burned at third second, right? Two nodes are burned at the same time, right? Okay, after that, right now at the 4, what is your current? Current will be 1. What is the parent of current? It's null, right? You are not able to access that part. That's why here what we have to do is we just have to ask parent ka null. They said yes, so do not access that part, right? Okay, after that, 1 ka left is 2. It's already visited. It's already visited, right? 1 ka right is 3. So it's not visited. Let's write here 3 and mark here 3 like this, right? Okay, now see, initially your flag will be false, right? When we start a new for loop, and right now it's true, right? Okay, after that, what we have to do is your I equal to 0 means first part is over with the node 1, right? Now it's time to run your for loop 4, right? Okay, now your current will be 4. I'm asking its parent is visited. They said yes. 2 is already visited, right? It's already burned, right? Now go to the left of it. It's visited. They said no. So let me write here 8 is true and add 8 into it, right? Okay, okay, so it's done and 4 is done. Okay, now after that what we have to do is we just have to ask, is this true? Yes, and yes, it's true. Let's increment that part. Now if you see here, I'm adding 3 and 8. It means that particular is burn at 4 second, that particular is burn at 4 second, right? Like this, right? Just assume like this. Okay, after that what's your size of q? They said 2, right? And I equal to 0. We just have to, my current will be at fifth, my current will be 3, right? Okay, now 3 ka parent will be 1. It's already burned, right? Do not burn that part again. Okay, now we go to the left of it, it's not there. Whatever, we go to the right of it, yes, we have something in the right. So when we start my for loop, what is your flag? That is false, right? Okay, and right now we go to the right of it, and what I'm doing is I mark add true because I'm burning that part, and add into your queue as well, right? Okay, after that what we have to do is that particular true will false will make true, right? Okay, after that, that is okay. After that we have 8 because I equal to 1, we just have to do the 8. Now when we are at 8, its parent is already burned, its left is nothing there, right is nothing there. So at the end what we have to do is we just have to ask, is this true? They said yes. Please increment that part because at fifth second I burn that part, right? That is at fifth second. Okay, now after that we have 7 here, right? We are at 7. Now I'm asking, its parent is burned. Before it, as I already tell, when you start a new, your flag will be false, right? And we go to the parent of it, it's 3. Is this visited? They said yes, it's visited, right? And go to the left of it, nothing is there. Go to the right of it, nothing is there. At the end you start to ask, flag is true? They said no. Okay, in that case do not increment it, right? Because nothing is burned right now, all the trees are burned, right? At the end, what's your time? What's your time? You just have to return that part. Time is 5. That's your output, right? Like this you have to do that. Okay, so I hope you understand the intuition what I want to tell you, but it's a little bit hard problem. Just do the dry run of it. It's very easy, right? Okay, so if you understand the dry run, so let me show you the code once again. Okay, so in that particular case, what we are doing in the first case, we just make a parent-child relationship using the map, right? So in the helper function, we do that part, right? In the helper function, we do that part. Okay, we just make the table of it, right? Map of it. Okay, after that, in the second node, second step, what we are doing is we just have to point. We just make a node which is null, and I just want to point that particular node to that particular target node, right? So that we can start, right? So that is the node. That's the second step, right? Okay, after that what I'm doing is I simply make a queue, right? So that I can put all the values and make the visited array so that we can mark that particular node is visited or not, right? Like this. And the node itself we are pointing, just mark that particular is true and make time is 0 and put that particular node into your queue so that we can traverse all the things, right? Okay, after that what I'm doing is I simply ask the size, right? And because at 1 second, at the first second we have only one node which is burning right now. That's why we make a for loop, right? Because we see at a case when we have two nodes which is simultaneously burning, right? That's why we just, whatever the nodes which is burning simultaneously, that will be in your queue, and that's why we are asking, hey, please tell me the size of it so that I know like how many times we just have to traverse that particular node ka left, right and parent, right? Okay, so in that case, we just point to the current, right? And ask the parent, whatever the parent we have using the map, go to the parent of it, go to the left of it, go to the right of it, and at the end, my flag will tell if in your for loop, if your flag, initially flag is false, right? If you see here, okay, in your for loop, if your flag become true, it means any of the case you are burning a new node, right? At the end of it we just have to ask, are you burning any node or not? The flag will tell, right? Flag is true, it means you are burning any node in that particular case. Simply time plus plus, right? At the end we just have to return the time, right? Like this, it's working fine, right? So let's submit and check it's working fine or not. Yeah, it's working fine. Okay, now let's talk about its time complexity. If you see in the first case, we are just doing the helper function where we just have to traverse each node one time, right? In that particular helper function, we just make a parent child relationship, right? It's order of n, right? We just traverse each node one time. Okay, after that what I'm doing is I just traverse my uh, tree again to find that particular target node. Again that particular find function will do order of n, right? Okay, after that what I'm doing is I simply traverse each node one time so that I can traverse its left, right, and its parent, right? So in that case also we just have to traverse one time, right? So in the whole the three steps, my complexity will be, my time complexity will be order of n plus order of n plus order of n, right? We can say that its complexity will be order of n, where n is your number of nodes, right? Number of nodes. Like this, we can solve this problem. Okay. So hope you understand the solution and intention. Thank you so much.